Hello again, my fellow Jeti users, and today I'm going to show you how to program something like a rotary knob or say a 3-position switch to behave just like a trim button in order to set something like the gain of your gyro. Now the point of that is that the gain of your gyro, or position of your servo if you want to use it for something else, is no longer dependent on the position of the rotary knob. It behave like the trimming switches, trimming buttons, that, once you've set it to a value, it will just stay there. It will remember it even with the knob back at the 0 position, and it will remember it when you switch off and switch the transmitter on again. Now you might think, well, that's dead easy. We do this. We go into fine tuning, digital trim, come down here, select our P8 knob, it's proportional, good. Set it to the gain channel, and there we are. That will work, won't it? Yep, it will, but there is just an operating problem with that. It will only give you one click of trim at a time, so you have to rotate backwards and forwards to get each click of trim. Whereas with a trim button, as you know, if you hold it down, off it goes, and it keeps going beep, 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 and adding the trim to it. So let's take that out, see how annoying it is, and I'll show you how to program the transmitter to make the rotary knob or 3-position switch keep beep, beep, beeping, adding the value to the trim until you turn it back to the center position. So just for the moment, we'll take that out. Oh, not that one. That's the one I need to take out. Clear that out of there. We can leave the gain in because we'll come back to it later. Right, so let's zoom back in. Okay. Now, there are 2 limitations to this program. Firstly, because we're going to be using the trim function, because it's the only thing in a Jeti transmitter that has this sort of memory, the maximum travel pardon me, that you can get for your gain will be 75% or minus 75%. The reason being that the trim programs allow you to set a travel up to maximum of 150%. And as I've said in many of my videos, trim settings are half of the normal travel value. So when you can set a trim of 150%, it will actually only travel 75%. But I think you'd probably say that for most gyros, you'd be very unlikely to want to get to a travel value of that anyway, so that should cope. And the other thing is, there is no way to use a switch to zero this out in a hurry. If your gyro comes loose, goes mad, whatever. So it's not suitable for use, in my opinion, with something like the iGyro or the Bavarian Demon Cortex, which don't have a separate off switch. You can't mix the value back to 0 like we would normally do with those gyros, because it's a trim value, not the function value. And therefore, I would suggest you don't use it with those gyros. It's perfectly okay to use it with a gyro that has a separate off switch or a mode switch. In the case of Jeti Assist, you've got both. And I believe that many gyros or flight stabilization systems used in multicopters, etc., they, I believe, may have separate on-off switches, and that's absolutely fine. Yep, you can use this with an iGyro or a Demon Cortex, but I'd suggest not, because there isn't that option to set the gain to 0 or switch off stabilization instantly. Okay, this request came from Rob Thompson, who also has his own YouTube channel, which is the letters RT-RC, if you want to look that up on YouTube. And he deals with various modeling topics, more biased, I think, towards the multicopter stuff, which I don't deal with. So if you want to use your Jeti in those things, you might want to look over there and various bits and pieces on those. So how do we get the transmitter to keep operating the knob as a continuous beep, beep, beep? Well, it involves two virtual functions and one virtual channel. So let's go in and have a look at our functions assignment. I've got three functions here: gain, which will be the final output, and it will run the channel to the gain, to the gyro. And I've got two virtual functions, G1 and G2. Servo-wise, we don't need a servo for G1. We need one for G2. We won't be plugging anything into it. That's why I called it a virtual channel. It's there just to provide a value for the next channel or function to work with. And then, of course, we have the gain output. Okay. Right, how do we start things going beep, 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 beep? Well, the obvious answer there is a sequencer. We can just make a one beep and tell the sequencer to go back and forward, back and forward, back and forward. So let's do that. Go to Advanced Properties, Sequencer. We'll pick Q1. Now, the switch is going to be, in this case, the P8 knob. And we want it to be on if we rotate it right or we rotate it left, but off in the middle. So how will we do that? We can turn the knob all the way to the right or to the left, open the switch field and rotate the knob back to the middle. Now it switches on the middle, but the two outsides are off, so we press reverse. The middle is off, and if I rotate the knob fully left, it goes on. If I rotate the knob fully right, it goes on. Okie dokie. And before we go any further, we'll come down to Advanced. We don't need to overwrite the channel. It's a symmetrical path, but we want it to cycle. So for as long as we have the P8 knob turned fully right or fully left, it will just keep going back and forwards, back and forwards, back and forwards through the sequence. Say OK to that. Come back up here. Now, the time values you want depend on how rapidly you want the beeps, but I'll set it up so it has a reasonable beeping rate. So at time 0, we want to put in a point with value 0%. Lovely. We'll come along to 0.2 of a second. Press the plus again. It'll put in a value of 0%. Now come to 0.3 of a second. Press plus again to put in a new point. And here we want to come to a value of, I press the menu button twice to get 100% steps. There we go. Now, come along here. Come along to 0.5 of a second, press plus to get a new point. It'll put it in at 100, that's lovely. Come to 0.6 of a second, press the plus to put in a new point, and take that back down to 0. Come back here, and we'll add in just another point. We'll go to 0.7, 0.8, press plus, puts it in at 0. That's the end of our sequence. And so now, P8 switched off. If I rotate the P8 knob fully right, we'll watch it go through the sequence back and forward, back and forward, back and forward, back and forward. Okie doke. You can see the output values flicking from 0 to 100. It actually goes up a ramp because of the slope between the fractions of a second, but it's so fast, it's not a problem. So it's basically going between switched off, so on, off, on, off, on, off, on. And if I rotate P8 back to the middle, it stops. If I rotate P8 fully left, it sets off back through that sequence. Okay, so far so good. Let's say OK to that. Come out of there, go back to our model, functions assignment, and G1, we're going to assign that sequencer as its control. So it's sequencer 1, I didn't bother naming it. No need to with something this simple. And so if I rotate the knob fully right, you can see the sequencer tick-tock, tick-tock, tick-tock. P8 back to the middle, it stops. P8 fully left, tick-tock, tick-tock, tick-tock. There we are. Now, the snag there is it's only going from 0 to 100, which is like pressing only one of your trim buttons, not the other one. We need to find a way of getting it to reverse when we swing P8 the other way. And there's no point thinking, oh, well, why didn't you create two sequencers? One with P8 one way, going to plus 100, and one with P8 going the other way to minus 100, because there's no way to combine them. Remember, when you do mixing, for instance, mixing only works at a function level, so you can't input the sequencers as a mixer. And you might think, well, what about a logic switch with the two sequencers as inputs through an OR function? For some reason, it doesn't work. It will only pick up the input A. So if you put the positive one in input A, it won't pick up the negative in input B. And if you put the negative one in input A, it won't pick up the positive one in input B. Don't know why. Strange. There we go. So that's why we've done it that way. Right, what do we do next? Well, we need to find a way of reversing that tick-tock, tick-tock when we turn the knob to the left. And we'll do that through a couple of mixers. So we come out of here, fine-tuning, free mixes, mixer. So from that first one, G1, we'll mix it to G2 and come to advanced. The value will be, for the first one, plus 100%. And the switch is going to be P8 rotated to the right, so that P8 to the right only will mix in plus value. So put the knob to the middle, open the switch, turn the knob to the right, there we go. So knob at middle, knob at left is off. The mixer will only work when we turn it to the right. That's that set. And now the clever bit which causes the reverse one. So plus another mixer, again from G1 to G2, advanced master value. This time we're going to minus 100%. And the switch, so P8 to the middle, open the field, rotate P8 left. There we are. Say OK to that. Say OK. And now the G2 function will only start its mixing. It'll do nothing, but it'll start the mixing. If we rotate the knob fully right, it'll pick up G1 and mix it positively. And if we rotate the knob left, it'll mix it negatively. Let's have a look at what that's doing to the G2 function. Well, we're not going to see it because it doesn't need a control there, but it does have an output to a servo. So we can have a look at the servo, and here we take a check there, G2, channel 5. So that's P8 rotated fully right. You can see it's working. I'll rotate P8 to the middle, it stops. Rotate P8 fully left, will it go the other way? Yes, it does. So that's how we've managed to get a flashing negative value if we turn the P8 fully left, nothing if P8's in the middle, and a flashing positive value if P8's to the right. Now we've got something we can use, in effect, as a trim button. So we come out of here, go into fine tuning, digital trim, down here. We left the gain in from what I showed you earlier. So now the input is going to be that servo, not the function, because remember the function's not going negative, it's the servo output from the mixing. And it was number 5, if I remember rightly. So we go here and we come down to channel. There we go, G2. Say OK to that. OK. Now, here's the biggie. If I rotate P8 clockwise, will it start ticking up the values here as I leave P8 clockwise? There we go. And if I rotate P8 back to the middle, it stops. And if I rotate P8 anti-clockwise, it counts down. It'll get to 0 and then go negative. There we are. Now, you might think that's a little bit slow, and yeah, I think that is. So just go to the sequencer and shorten each of the 3 legs, i.e. the 2 that are at 0% and the top hat. I think I've put 0.2 of a second in each one, didn't I? So you could take them down to say 0.1 of a second, or one of them down to 0.1 of a second. It'll start shortening it. Come along here now. The trim step, 2%. Remember, it's a trim, so that will only step 1% of servo travel. So at the moment, you would have to wait quite a lot of steps to get the full travel. You might want to increase that, say 3 or 4% will give you bigger jumps each time. Importantly, you want to set the rate to 150%. Otherwise, you'll only get a maximum travel of plus 50% or minus 50%. Okay? So set that to that. Let's go to a trim step of 4%, see what happens. Come back here. Okay, let's see the value. Now you should be getting roughly half of that as a servo output value. Let's take it back down to 0. Set the knob back to there. Say OK to that. Let's have a look at the servo output, which should be, I believe, number 6. Yep. So number 6 is the gain function, gain channel for your gyro. Off we go. There, bigger steps. So you're probably better off with slightly smaller steps, say a 3% step in the trim, and a faster sequencer. Right, I'll stop it there at 39%, and I'm going to switch off the radio and switch it back on and prove that it has memorized that. Let's have a look at the servo. There you are. It's memorized it. Now, what's the point of this? Well, it means that you don't have to put the knob back at a specific location to keep the gain. You don't have to, having set a gain, then go and manually put it into a function curve value or some other output value. You can just walk away and leave it. And if you set this up on multiple models, then as long as that P8 knob is back at the center each time you switch a model on, you're going to have the memorized gain values. Well, that's it. You just don't have to do any more programming. Once you've found that gain you want, put the P8 back at 0 and leave it. Just a hint then, of course, that what's important there, go to Advanced Properties, Stick Switches Setup, go to P8, and set a required pre-flight position, which would be the center, so that when you switch the transmitter on, if accidentally you've knocked P8 off center, it will force you to put it back to center before it will transmit. One other little tweak you can make is how far you have to rotate the knob for it to actually start doing the trimming effect, and that is set here. So if you rotate positive, you've got to get 3/4 of the way round before it'll start picking it up. And same with negative, minus 75. You might think, for safety's sake, you want to have to rotate the knob virtually all the way for it to start doing the trimming effect, in which case you take those up to, say, 90, 95%. You might want to just switch it a small way for it to pick it up. So I'm going to turn the P8 knob a small way. See, here we are, showing me rotating the P8 knob. I'll take it just to there. At the moment, if we listen for the beeping, there we go. Got to take it all the way there for it to pick up. So maybe I want it much more sensitive, so I don't have to rotate it far to get it. I'd like it there. So all I have to do is then wind the switch on number down until we get the beeping. There we are. Oh, it's gone to the maximum, that's why it's... I think the trim had reached its maximum, which is why it was stopped going. So if we put it back to there, So we can set that, go to -27%, and now with just a little turn of the knob we get the trimming effect taking place. Okay, so hope you find that useful. There you can turn any 3-position switch or rotary knob into a repeating trim output.